It's time to fire this thing up.
Welcome aboard ShipShape TV Essentials. This is your port of call for the most impactful upgrades, expert advice, and hands-on solutions from seasons past. This episode is proudly brought to you by thru-hull, because anything worth doing is worth doing bright. From cleaning to protecting and perfecting, thru-hull has everything you need to keep your boat shining. Don't just go boating, go showboating. Now, let's hoist anchor and set a course for another exciting episode of ShipShape TV Essentials.
Countersink some holes, screw it down, and I'm again going to let this last out. Dry fit this thing into the boat. Take a look at this. Hi, I'm John Greviskis. It's good to have you working around the boat with us. This is a bronze strainer that came off of a recent model boat here at the boatyard. It covers a thru-hull fitting. Now take a look at the pitting and the corrosion and just how weak the metal has become. Now this is a classic example of what's called galvanic corrosion. The metal has been attacked by a stray current in the water right at the boat owner's dock. Now here's the really scary part. This fitting is less than 2 years old. This is the best part of the combination of the strainer and the thru-hull fitting. The thru-hull fitting actually crumbled in our hands. Now the boat owner is very fortunate that we caught this in time. If the erosion of the metal had gone all the way through that thru-hull fitting, he could have very well lost his boat. It would have sunk. Now fortunately, the problem can be resolved pretty inexpensively and with just a little bit of effort, and that's what we're going to be getting into today here at ShipShape TV. We're going to be installing a bonding system to our own 1978 24-foot Stamas project boat. We're also going to cover sacrificial anodes, lightning protection, and the importance of a galvanic isolator. So here's the deal. It's a trade-off. How about if we get you to spend the next 30 minutes with us, and in exchange, right after I gather up a few tools and materials, we'll let you in on a few more ways to make your boat shipshape.
This is a real working 28-acre boatyard located in Stuart, Florida, on the shores of the Okeechobee Waterway. It's home base for ShipShape TV. This deep stretch of water connects the Atlantic Ocean to the Gulf of Mexico. And now, once again, here's the host of ShipShape TV, John Greviskis.
Thanks, Buck. First thing that we need to do is get a baseline to work off of in order to know what the potential voltage the water will carry right here at the boat's dock. And what I've got here is an ordinary voltmeter that you can pick up at any quality marine hardware store. They run about 50 bucks. And how it's set up is I have a silver chloride attached to one side of the meter, and I also have a zinc on the other side of the meter. And what we'll do is we're going to drop both of these over the side of the boat in order to get that reading. Let's go ahead and do that. I'm going to set this on the deck, and we'll drop these two leads over the water. Now the water right here at the dock is reading about 970 millivolts. Now we can also find out what the potential is for other metals around the boat by hooking up this lead to some of the different accessories, like a bronze thru-hull fitting, for example. If we want to know what the potential is for bronze, we would just hook this alligator clip right up to the bronze, and we'll take a reading, and we're going to do that next. Let me get this thing up. And now, I'll again put this silver chloride over the side, and we'll see what we're dealing with. Now we're right around 50 millivolts, and what that's telling me is that the bronze is not being protected. It's being freely eroded, or every day a little bit of that metal is coming off of that part, and that's not good. So what we need to do is again install a bonding system. And what a bonding system does is it ties all of the metal accessories on the boat to a single strap or wire, copper wire. And then that copper wire would get hooked up to an anode like a zinc or a magnesium. But the first thing we need to do is haul out and pressure clean the bottom. So I'm going to start up the boat, and we're going to do that. Now, we've been in the water since spring, and we have a little bit of fouling that we need to contend with. Now, if you notice, we have a containment system right here at the boatyard. That's so that anything that comes off the bottom of the boat when we're pressure cleaning it doesn't go back into the waterway, but rather goes down into this drain. It then goes over to a huge filter in order to get processed. Now, if you'll remember, our bronze thru-hull fitting was freely eroding at 50 millivolts. And what we need to do is we need to put some sort of sacrificial metal on the boat, like a zinc or an aluminum anode, in order to protect the metal from freely eroding. And we need to cover the highest eroding metal that we have, which is this right here. This is an aluminum engine bracket. And that in our type of water is going to read right around 700 millivolts. So when everything is said and done, when the bonding system is in place, we need to make sure that our sacrificial metal is going to be at least 200 millivolts above our highest eroding metal. Again, this being 700, we need to make sure that when everything is said and done, that we're right about 900 millivolts. Now, the reason that this galvanic erosion or corrosion takes place is because salt water or fresh water with any type of mineral in it will conduct electricity. It's called an electrolyte, and that's what causes this whole problem. But I've got a little bit more fouling here that I need to clean up, so I'm going to get busy. Now let me show you all the different metal accessories that we're going to be tying into this bonding system. We have a bronze thru-hull fitting right here. We have another one on this side. We have two a little bit farther forward, one right here and one right here. And we have our aluminum engine bracket and these two outboard engines. Now we also have to deal with a few accessories inside the boat, like an aluminum water tank, an aluminum fuel tank, and some accessories that indirectly come in contact with the water. I'm talking about our stainless steel pump for our air conditioning unit and a couple of bronze vented loops for our head. Now what I've done is I've invited an expert in galvanics to join us today to give us a better understanding of exactly what we're up against today. Let's go up topside and meet him. Well, Brad, thanks for helping out today.
Pleasure to be here.
Can you tell us what exactly a bonding system is for?
A bonding system is a way to tie all of your metal accessories to one sacrificial anode by using in many cases, a strap very similar to this. A lot of the high-end boats will have a bonding strap like this already laminated into the hull during the production process.
What is this made out of?
That's a zinc-plated copper strap.
Okay.
And again, they put it right into the hull of the boats, and that's what you hook up all of your metal accessories to one, and then again to
you
one.
Use like copper wire
right.
to this metal strap, and then that goes what?
That goes
anode?
to an anode, one anode, as opposed to putting a anode on all of your fittings and all of your accessories, which is literally impossible to do.
Especially like on a thru-hull thing.
Right.
It'd be very
right.
tough to put a zinc or a magnesium, on that.
Right.
Now we don't have that luxury here, Brad. We don't have one of these bonding straps laminated into the keel of the boat. How do we put a bonding system in the Stamas?
For bonding alone, what we would do is run a 10-gauge tin-plated wire, the length of the hull, and then attach again all of the metal fittings to that one wire, and then that again to the sacrificial anode. We're going to do something a little bit different today. We want to offer some lightning protection for the boat, so we're going to run a heavier gauge wire to a Dynaplate as well, and that will give us some lightning protection.
Okay, great. Well, why don't you get busy putting in this bonding system, and I want to find out more about this Dynaplate. Now, the reason I pressure cleaned the bottom of this boat was to accommodate this thing right here. It's called a Dynaplate. And what Brad was talking about, this piece of hardware is actually going to protect any passengers, or the boat for that matter, from something that we get a lot of down here in South Florida. I'm talking about lightning. And basically it's going to be attached right to either the back of the transom or the bottom of the boat. And with us also today from the guest company is the vice president. His name is Frank Alban.
Nice seeing you again, John.
Frank, I want to thank you for coming down here. Talk to me about these Dynaplates. What are these things for?
Well, in a nutshell, they give a lightning protection for the current to go to ground, ground being the water. It's equivalent to a ground bar that you've seen with a barn, where you have a lightning rod, a cable, and a ground bar. This represents the ground bar in a boat.
Okay, well, this actually kind of looks like a lightning rod to me.
That's a lightning spike that's used in most sailboat applications, that you put that on top of your spar, run your cabling down from the spar down to your ground plate or ground bar.
Okay, now talk to me about this metal. This is not solid.
No, John, this is what they call a centered metal. This is made up of spheres, and each sphere's got a certain amount of area. So this is an equivalent to 100 square feet of copper.
Wow.
A sheath.
Okay, now why do we have different sizes here?
Well, it's basically made up of different size for different size vessels. This is a big sport fishing plate. This is 144 square inches, and it's also used as a counterplane for the single sidebands that are prevalent in the sport fishing industry.
Okay, now talk to me about price. What do these things run?
Well, from $65 to $350.
Okay, and how do we actually mount this thing into our bonding system?
Well, very simple. We mount it, we put it up on the hull, we mark the two holes, we drill a thru-hull through, we put a backing plate up underneath it, we put some good sealant, and we put our through bolts through.
Okay, now in essence what we're trying to do is we're trying to channel the lightning.
We want to get the path of least resistance and least current, meaning straight line as possible.
Okay.
As we set it up on the Stamas hill here, we've got it set up tied into the outriggers and then also in the bow rail, where all their metal, coming down almost in a direct path to the center line of the hull. Again, as a lightning comes in, you want to give the path of least resistance into your ground bar or your ground plate.
Well, Frank, thanks for all the information. If we're going to get this project done, I've got to get back on the boat and get started. We'll check back in with you in a couple of minutes. Thank you.
As John puts away his tools for this project, let's see what the G-Man looks for when he's buying a used boat.
A hull and deck joint is going to tell you a lot about how a boat is going to ride and sound while out in an open sea. Unfortunately, they're usually masked by some sort of a rub rail. So what you need to do is you need to get inside the boat and poke around. Look under a gunnel or perhaps up forward in an anchor locker. Now here are some of the most common examples for you to take a look at. You also want to take a look at what type of fasteners they're using for this hull to deck joint. My personal favorite is a stainless through bolt with some backing washers. Then would be a pop rivet. My least favorite would be a stainless steel screw. Also take a look if the joint is sealed or not. Remember, the stronger the hull to deck joint, the better the boat's going to ride and sound while out in the open sea.
We hope this tip helps you, but now it's back into the action with John.
Well, Brad, how's the installation coming along?
It's come along real well, John. I've finished laying our 4-gauge wire along the hull, as you can see here.
Right.
I'm in the process of running the 6-gauge wire to the various accessories we want to include in our bonding system.
Now, is there a reason that you chose a green wire here?
Yeah, there is. Green is the international color as prescribed by the American Boating Yachting Council for bonding or grounding. This will differentiate, obviously, the wiring from any of the red and black wires you see in the rest of the system, in a DC system.
Now, how exactly did you connect that wire to the fiberglass hull?
Well, what I did first is I drilled a small pilot hole into the fiberglass right here. Then took a stainless steel screw and our tie wrap clamp, used the stainless steel screw, put the tie wrap clamp down, and then of course put the tie wrap right around the wire. And I did it every 18 inches, as you can see, which is the best way to clamp it down.
It's also according to code, okay?
According to
that's
code,
good.
correct.
Now, how are we going to connect our different metal accessories up to this 4-gauge wire?
Well, what we're basically going to do first is obviously we take the 6-gauge wire, and I stripped off the ends, as you can see right here, put on some heat shrink, crimped on a terminal end. What we're going to then do is take each one of these connectors. We're going to connect right here, and if you can look down here, we've got several different types of connections. You see one here on one of our through-hull fittings. We've actually welded on a nice little clamp area where we can put through the connection, very similar to this right here.
And then connect it right to that. That is really slick.
This is another type of connector right here that where we just slip it right over, clamp it down using this, and then we use the terminal end right here.
Fantastic.
And then we tie everything together through the boat.
Now, do you have a lot more to do here? Or
I've got a little
close?
I've got a little bit more to do in terms of tying everything together, but what you really need to do is show us how you're going to tie it all to the bracket.
All right, well, that's a good point there, and there's a reason that we need to tie it all to this aluminum engine bracket, because this aluminum engine bracket is what's going to house our anode. Remember, a single sacrificial anode is going to now protect this entire system. This is how we're going to do it. We're going to drill a hole through the back of the transom, very high up. We don't want any water getting into the engine bracket back there. And if you'll notice, there's some stainless steel bolts going all the way across. Well, that's where the flange, there's a 2.5-inch flange on the aluminum engine bracket, bolts up to the boat. We're going to take a drill and we're going to go all the way through the transom and all the way through the aluminum engine bracket. Then what we're going to do is we're going to take a little larger drill bit and we're going to drill a little larger hole into that transom, and that's to accommodate a bolt. Now on the back side, inside that chamber in the aluminum engine bracket, I'm going to take a tap and I'm going to tap some threads. And this bolt will now have some very good contact going into the aluminum engine bracket. And remember, our anode is on the bottom of that aluminum engine bracket, and that's what's going to protect us all. Then we'll simply take a lead, we'll hook it onto the bolt, and everything is bonded in together. Now they need to use a travel lift to block up another boat, so they're blocking us up, and I want to show you where we're going to be mounting this Dynaplate. Now again, our outriggers are the highest point on this boat. And we're going to be running that wire straight down to the bottom. Basically, where we're going to be putting this thing is directly at amidships, and I'll mark it out with a pencil, and then I'll come back and I'll drill a couple of holes into the bottom of the hull, and then we're going to through bolt this Dynaplate. Now again, there are two through bolts. This one right here is a special one. It's actually gold plated, and it gives excellent conductivity. We'll attach our entire bonding system to this, and we'll seal up the holes with polyurethane sealant, and we're back in the water. Now what I want to do is I want to find out a little bit more about those sacrificial anodes. Let's go over and meet Chris from Canada Metals. Chris.
John.
Welcome to the boatyard.
Thanks for having me.
Now what do we have set up here?
This is a variety of different types of anodes, or sacrificial metals as they're commonly referred to.
Now the reason they call them sacrificial is because when these things are mounted on the boat, below the water line, this metal is being attacked by the galvanic corrosion rather than your expensive metals on the boat, like your outdrives on your engines or your bronze through-hull fittings, right?
That's right. There are three main types of anodes on the market right now. That's zinc, aluminum, and magnesium, all of which are manufactured to U.S. military specifications.
All right, I'm familiar with zinc. That's primarily used in salt water. Where else would you use the zinc? Would you use the zinc in freshwater?
No, absolutely not. Zinc is just not active enough to be used in freshwater. Something like that, you would probably need a magnesium. As you can see, it says freshwater only on this product. Magnesium is a very high potential, and what it will do, it will raise the potential around the boat, thus protecting the boat the way it should be.
Well, why don't we just use the magnesium in saltwater then as well?
Well, that's a good question, John. Magnesium can't be used in saltwater because what happens is the electrical voltage gets so high that it actually can damage your boat. For example, paint and steel will damage at about 1200 millivolts, where aluminum, such as your outdrives, they can damage at 1100 millivolts.
All right, now what size zinc, because we boat in saltwater here, do we need to use for our Stamas? How do we determine the size zinc to put on the boat?
Well, that's a good question, John. The first thing we have to do is we have to contact a manufacturer, such as Stamas, and ask them what kind of zincs are spec'd for their boat. Now, they have the engineers, they've done the work, so they should be able to tell you.
I agree with you in a lot of cases, but we've done a lot of modifications to the boat, like the aluminum engine bracket. It's not the same as it came out of the factory. Is there some kind of a starting point? Do you have I've heard that you can use like 6 inches of zinc per 100 square feet of either aluminum or steel. Is that like a starting point to go off of?
That would be a good starting point. What I would recommend is take a corrosion test meter and take a test around your boat, and from there you can really quickly find out if you need to add a zinc or decrease it in those type of water environments.
Well, this is what we're going to do. We're going to start off with one of these 5-inch rudder zincs. I'm going to put it on the aluminum engine bracket, and that's going to give us our starting point, but then our project's going to be pretty much complete. We'll get it back in the water, and we'll do some figures. I'll see you out in the water.
Perfect.
Now, I've gone ahead and hooked up my voltmeter to our bonding system, and now I'm going to drop this silver chloride again into the water. And I'm really glad we put that lightning protection into the boat, because as you can see, we've got a little bit of rain going on here, and you never know down here in Florida if you ever get some lightning. But let's see where we're at. Okay, we're at 860 millivolts. Now, you'll remember that our aluminum was 700 millivolts, and we need to protect it by 200 millivolts. So we're just a little bit shy. We need to put just a little larger zinc on the boat, and our bonding system is going to be a total success. We have successfully protected all of the metal components from each other. But Frank, we're still not protected from a dock, and we're still not protected from a boat that's right next door to us. They might have an electrical problem where that current could actually come over and just start attacking our metal and literally eat it away very fast, like I showed you at the top of the show. So Frank, how do we deal with that problem?
Well, what we do is simply put a galvanic isolator into the green ground line of your AC connection, and that green ground line is bonded to your engine block along with your bonding system.
And what does that do?
We have a diode bridge in here, and the stray currents cannot break through the diodes on the DC end, yet if there's a short for the AC, it will break through on the AC end.
Okay, so if you have 2 DC systems like 2 boats or whatever, this will isolate you from that other boat or from a dock.
That's correct.
Okay, and give me a ballpark price on something like that.
With a non-ground monitoring system, about $85. With the ground monitoring system, about $175.
Very good. Well, Frank, I need to thank you.
Thank you.
And I need to thank Brad as well as the entire guest company, along with Chris Powells from Canada Metals. But our project is just about done. The only thing that I have left to do is do a little bit of cleanup. So I'm going to get this voltmeter out of the rain here. It's sprinkling a little bit. We'll be all set. What a great show, and what a critical topic. You know, there's a lot of stray current that's going into the water these days, especially around the dock. And your boat needs to be protected from it. But you know what? We have a little bit of bonus time left over today, and this is where we answer your questions, either from the letters that you've written in or from emails that you've sent to us over our internet address. But before we get into today's question, we want to give you those addresses. Buck, can you do that?
Our mailing address is Shipshape TV, P.O. Box 31561, Palm Beach Gardens, Florida 33420. Or if you have internet access, the address is shipshapetv.com.
Okay, here's today's question. It comes from Keith up in Spokane, Washington, and Keith has an Evinrude outboard, and he wants to know how to change out an impeller. Well, good news for you, Keith. We have another special guest with us today. He's from the OMC testing facility. His name is Eric Hess.
John.
And Eric, you know what Keith wants. Can you show us real quick how to do this maintenance procedure?
Sure. Keith, the first thing you're going to do is drop the lower unit from the engine. And I like to lighten the load by removing the prop because it is heavy and cumbersome. It's good to have a helper when you're doing that. First thing you want to do is disconnect the shift rod. Now, other models will vary. Some have spline shift rods that are very short, and some have a pin at the top. You'll then want to remove the 6 mounting screws, and not to forget the one underneath the trim tab, because that usually gets people.
That's the one that gets them.
Mm-hmm. And once you have dropped the lower unit, you can put it in a nice stand. John's built a nice one here, or put it in a garbage can and brace the cavitation plate and spray plate around the rim of the can. But you want to kind of keep it upright and steady while you're working on it. Once you've exposed the water pump housing here, you'll want to remove these 4 screws, lift the housing up, and then one thing you might want to do if you have a lot of pitting or corrosion around here, John, is you'll want to sand this area in order to remove the impeller.
So like with emery cloth?
Exactly, exactly.
Now, how do we get that the actual old impeller off?
Okay. What I like to do is I'll bridge the impeller hub with a pair of channel locks, and then I will turn opposite the rotation of the impeller, which would be counterclockwise. That unlocks the cam that locks it onto the drive shaft.
What about for really old outdrives?
Really old outdrives, you might have to get creative. I've had to use a chisel before to actually chisel the hub away. Just be careful not to damage the drive shaft.
Okay, so we've got the impeller off. How do we put the new one on?
Okay, one thing you want to do is you want to inspect that impeller housing cup and plate for any deep grooves, because that might reduce the efficiency and the life of the new impeller. Some slight grooving is normal, but you don't want any deep grooves in there. After you put on your new impeller, you want to make sure that you get the cam all lined up down there, and then you'll slide the housing on with a little bit of grease or lightly oil in the inside of the
What
metal
type of
cup.
grease should we be using?
Well, just for the inside of the hub, it just can be any kind of grease, because what you want to do is you want the impeller to be able to slide into the metal cup as you're turning the drive shaft clockwise. Same rotation is what it is. Now for the splines, you'll want to use a heavy-duty adhesion OMC Moly-Lube spline grease. Because of the RPM this drive shaft turns, it can sling the grease out, and then you'll be left unprotected.
Okay, and one last point is when you're putting your bolts back in to your outdrive, you might want to use some anti-seize or some Tef gel to keep the stainless from seizing up with the aluminum. Eric, hey, thanks for your time.
All right, great.
Guys, we're out of time, and we want you to do yourself a favor. Until we see each other again, you try keeping your boat ship shape. You know, Eric, I had another question.